Okay, okay, so it's like morning 3:24. I have not slept last night. Let me show you. Okay, I am on full screen. I can't show you display. When I will start this display recording, I will show you. For now, okay, just a minute. Okay, yeah. Wait. I don't know why I want to show you time. Just I love it, so I'm showing it to you. Okay. Is it visible? Yeah, it is 3:25 a.m. Yeah, and so yes, it is. And I have one light over here. I just on it, and yeah, the session is like totally unplanned. Just I got in mind that I have to post every week one at least one video, and also I skip my last week, so I don't wanted to skip this week. So yeah, I'm making this video. Okay, so is there any motive? Like yes, it is. It have one motive. So what I mean is, I wanted to make this video like last week, and last week, the part that I'm gonna explain in this session, I have learned this last week, and this week gone like totally waste. I don't know what I've done in this week. Like one August 15th, August 14th, and August 13th were like just gone like this, and August 12th it was like Monday. Okay, so on Monday I just enjoy, I just do time pass, like because I don't like anything to do on Monday, and August 15 gone, August 16, August 17 also gone like this in air, and today is okay, sorry, August 16 is Friday, and Friday is just gone like this, and August 17 was Sunday, means last day. That has gone also in here. I don't know how, but this week was like totally waste. I have not learned anything in this week. Whatever I'm gonna discuss with you in this video is the knowledge of last week. Okay. So why I have not made any video like last week? The reason was I was like I wanted to make a little perfect video, but as you know, the perfect things doesn't exist. Actually, what perfect means? Okay, so today I'm gonna explain you about this Newton light particle theory, Huygens wave theory about the light, and Young's double slit experiment, and also yeah, display is not on, or else I used to show you that what I'm gonna explain. Okay, this is all the topics that I'm gonna discuss about, and I said you like something about perfect. So I was thinking to learn about this de Broglie hypothesis. Like de Broglie hypothesis, everyone know about that, but I want to learn like little bit in more depth, and I also wanted to learn on this matter waves, and also I want to know about this Schrodinger wave equation. Okay, so there were like so many things that I wanted to learn, and just a week gone in waste. So I don't wanted to waste my this week. So I just wanted to start it. I just wanted to post a video. Okay, so yeah, I'm recording this. I will post it. I don't know how it is gonna go. Like the session is like again it is unplanned. Like um till 2 o'clock I was just doing revision about this, what we say, Newton's particle theory, and Huygens wave theory, and Young's double slit experiment. I was just doing revision. After doing revision, I thought to learn this de Broglie hypothesis. Yeah, I was just gonna get started, then I thought that just I got one thought that why not make a video on these three topics, okay? Because like today is Saturday, tomorrow is Sunday. Sunday will be like I will not get any time to make video, and I don't know what will happen tomorrow because day after tomorrow is Rakhi, August 19. So it can be like I can also get some household works, like anything can be happen, or some of my relatives also can arrive to our house. So I don't wanted to risk it out. So yeah, that is also one reason that I'm making this video at like at night at 3:30. Okay, so yeah, till 2 I was doing revision. So at 2 o'clock I got this start. Then I felt like little bit anxious, and then I had my food, and after that something happened. Then the time went like 3:30. Okay, so without wasting time in this discussion, oh yeah, I want to say you about this Python part. Okay, so in Python, this week was like totally waste. In last week I learned like little bit theory part, like what we say swap. Okay, and about the symbols, and about the variables, about the syntax error and all, and like it was like totally theory part. What you call them operators. Okay, so yeah, I can discuss about this, but in not obviously in this because this is for physics. I can discuss it on like tomorrow or else some other time. And why I'm not making video on maths? Maths is like my favorite topic. Maths is just, yes, I just love discussing about the maths. But the problem is like, as I said, I'm like a little bit. I am getting little bit lazy. I just don't wanted to do like some work related to anything. Like I'm just enjoying my college life. That is also one reason that I am not making video. But yeah, I will make sure that next week I make one video on this deep progress hypothesis and Schrodinger wave equation. This is like and also on matter waves. Okay, like what is matter waves and all. I will properly I will analyze it, I will learn about it, and I will try to give you explanation about this. Okay, so yeah, enough discussion. Now I think we have to start our main topic, and yes, so let's start it. Okay, so our display capture is on. First let me show you the time. Yeah, it is like 3:23 a.m. 3:23 a.m. Yeah, I just hope it is visible to you. Yeah, it is. Okay, let it be. And yeah, I got like some simulations for you that I'm gonna discuss about this. This is for Young's double slit experiment, like slit weight. We are gonna like discuss on this, and this is on diffraction part. For this I got this, and this is just string theory, just for fun. And this is, I don't know, just kept it over here. And this is time. Okay, these are the tabs that we got. And okay, wait a minute. Yeah, okay, this everything is like stopped. Okay, done. Side view, what is the side view? Okay, top view. Great. So yeah, let's start with actually whatever I say on this mic I can hear in my headphones, so it is like little bit satisfaction. So yeah, I'm just doing it. Okay, great. Yeah, so very um yeah, Okay, so let's discuss about this Newton's particle theory. Okay, so what is Newton's particle theory? So according to Newton, he compared light with Newton's particle. Okay, like with particles. Okay, like particle. Okay, so what he said is, he said light is form of particles, and particles he compared with a ball. Okay, before going to this topic, like some people have this doubt that if Newton is wrong, if Eigen is wrong, then why we are learning about this? So we are learning about this just because you don't get like if like some students they what they do is whatever professor is like whatever they are learning it they get one doubt that why not this, why they have not compared this with particle, like what happened, like what is wrong in that. So just to say just to explain that what is wrong in that, one thing is that, and second thing is just about the imagination, like how you can imagine, like how you can imagine things like so many times it seems correct but it can also get wrong, and it's not that they were like totally wrong. Like Icon was not totally wrong. Because of his wrong assumptions, D block we got like little bit. He made little bit improvement, and with this small improvements, we got our light particle theory and wave theory. So yeah, we can't ignore the wrong theories, wrong explanation. Like we have to learn that why they were wrong, because everyone have learned about Newton's laws of motion, right? Because of Newton's laws of motion, you got your 50% 11 syllabus, and 25% the whole physics syllabus is like just based on Newton's laws of motion, so you can't ignore him, right? The whole mechanics is based on Newton's four laws of motion. Okay, don't discuss about this. Let's discuss about this, what we say, particle theory. Okay, so what you have did is you have compared uh, particles, like he said that light is a form of particles, and he compared particles with a ball. Okay, so what you have said, let me draw it for you. So he said um, it is just a ball. Okay, so yeah, so see it. Okay, how to use this? Okay, yeah, it is. So what you have said is you have said like ball is like when we throw it on ground, when we throw a ball on a ground, it get reflect back like this, and it goes like this. Okay, so in the same way, what you have did is you have put one like a mirror over here, and you passed like light on this, and he said that light like particles fall on this and they get reflect back over here. Okay, so what you have did, let's take a brush. Okay, so now particles are like coming like this, they will intersect here, they will make one angle, and they will get back over here, and they will just go like this. Okay, they are coming like this in the form of particles, and they are going like this. This is angle of incidence, and this is angle of um, reflection. Okay, so now what happen is if this is angle of incidence, this will be angle of incidence, right? Okay, so and like uh, uh, just imagine uh, like a line like this which is perpendicular to mirror. Okay, imagine a line from this point, it is coming here and it is perpendicular to the mirror. Okay, so the angle between the imaginary line and the particles that are going on the mirror, the angle between them is angle of incidence. Okay, this angle and this angle is equal. So what we have done is we are breaking it into particles. Like in kinematics, you would have learned that we convert them into vector form. Okay, like if here it is like going with v velocity, then down it will come with v cos theta velocity, and at for me it is right side, and for you it can be left. Yeah, for you also it will be right. Okay, so yeah, it will go in this direction and the direction will be v sin theta. Okay, so why I'm doing this derivation? I'm just doing this derivation to say that angle of incidence is angle of reflection. Okay, with this you have explained with this theory you have explained the point of angle of incidence is equal to angle of reflection. Okay, so yeah, let's break it also. This here it is going with wait a minute. Yeah, it is no, I think I have done something wrong. Angle of incidence. Okay, so we cost it and no, yeah, just a minute. So here this is angle of reflection, and this is going in this direction v with v cos theta, and because why I am taking this direction, because it is going like upper direction. Okay, so like here we can't take like downside, right? Like if we take like v cos theta in the downward direction, then it should come like in this direction, but it is going in this direction. Means if okay, see this particle. Okay, if this is going in this direction, then what you will do, you will convert it into, if you want to convert it in vector form, if this is going in this direction, you will convert into this and in this. Okay, and if it is going in downward direction, you will convert it into in this particle and in this particle. Okay, so here it is going downwards, so we have converted into this into two particles. One is like at downward direction and one is like at right direction. Okay, so I hope I'm able to explain you in like little better way. So in this direction it is going with v sin theta. So you can notice one thing, that v sin r and this is v sin I. Okay, you can notice that in right direction it is going with same velocity. Okay, this is going with v sin r and it is going with v sin I. So how we are saying that this velocity is same? This velocity is same just because how it with how much speed it came like downward direction, in the same speed it is going with in upward direction. Just the thing it have changed is direction. Okay, the velocity is same, and like the velocity is same, and with this we are proving like that v sin I is equal to v sin r, and we get cancelled and sin I equal to sin r, and because of this angle of incidence is equal to angle of reflection. And mainly we learn it in kinematics, and here we are learning just to say you that uh, um, just to say you that what I'm sorry, like physics is little bit weak part. Like in explanation I get weak side, but yeah, physics is mine, it is good, but in explanation I'm getting little problem. But yeah, with the time I will make it better. Okay, so why we are doing this? We are doing this because I love it to explain you. Okay, like I love just this particles, like how we compare this ball with particle, and I want to explain you that why angle of incidence is equal to angle of reflection, and where I have got this idea. Okay, and about this vector part, like why this vector converts into this direction and this direction. You may get a doubt on this, so if you want I can also explain this, but it will like go in mass direction, and for this you have a separate chapter in your 2th standard vectors, you can learn over there. But yeah, I just I just like to explain like this parts. Okay, so the main point is I have compared the particles with ball, and in balls, like when we throw ball on ground, it get reflect back. Sorry, it get back to like with what force we throw ball on the ground, it get reflect back like with the same force. In the same way the light also get reflect back. He gave this point. Okay, and because is Newton's laws of, like Newton's 4 laws of motion were like so famous, say in the same, because of this reason every scientist have believed him that he is Newton, he will always be correct, and they believed in like for 150 years. Okay, for coming 150 years they believed Newton's theory is correct. Okay, and at the same time the Eigen also proposed one theory named Eigen theory. So what Eigen theory says? So Eigen theory, okay, so Eigen theory says that light is form of a wave. Okay, and more of it was like little bit correct. Okay, that it was like little bit correct that light is a form of wave. Okay, so like light is a form of wave. Actually I've said that every matter is a form of wave. Okay, and like you have compared the light with water, like in how, if we, okay, sorry, uh, Newton also explained about this refraction part. Okay, let me explain it for you. Like as I said, the session was like not at all planned. Like I'm not planned what I'm gonna teach. I just know is I will teach you Newton theory, Eigen theory, and Young double slit experiment. Okay, so yeah, Newton also have explained this diffraction law. Sorry, I'm saying diffraction. Um, when we okay, let me say you experiment, you will get refraction. Okay, refraction. So you have explained about the refraction also. So what you have said is you have said that every surrounding you have some attraction force. Okay, like this object, um, like on this object there is like one attraction force. Okay, it is coming from this, it is this from every direction the attraction force is on this particle. Okay, because from every direction it have some attraction force, every force get cancelled out. Okay, like yeah, so now what happened is, okay, so just imagine that in this bottle we have some water. Okay, so when this particle comes over here, like at the edge of, like now this is, just imagine this is a light particle. Okay, and in this is a water, but I know I am like saying a lot of things to imagine. Just imagine it. Okay, because physics is just of imagination. Like here we have like some 3D experiments, but This I don't think this get like this give that much help. How much this things give, because my physics sir Salim sir have said this, that physics you have to learn just from imagination. How good your imagination is, that good is like your physics. Okay, like, okay, let's discuss about this some other time. First, let's discuss on this. Okay, this is the particle. This is the water. So, what Newton have said is, whenever particle is going from one medium to another medium, there is a attraction force that is getting disturbed. Okay, like now at this point, when it is like just attached to the water, what is happening is like one medium has like some extra force, and it is like bending over, it is like attracting it over it. Okay, like here the all forces are not getting what we are saying here, all forces are not getting cancelled out. This this bottle have like a little bit more of attraction, and it is getting bent over here. Okay, okay. Yeah, it's fine. So yeah, so what happen is, when it get bends, like if the light is like coming like this, it like it should go like this, but yeah, we can draw it. So uh, if light is like coming like this, okay, it get like little bit bend. Okay, like just it doesn't get bad. I sorry for this, but exactly I don't remember like in which direction it is used to get bent. I just remember is that it used to get bent, like it can it used to get depend on the angle, the critical angle. Okay, like there is to be angle between, like it is a normal, this is angle of incidence, and angle of refraction, and here the angle of incidence and angle of refraction is not correct. Okay, like here also we can do that, what we say, vector form, and we can compare, and in this vector form you can see that sine theta will not be equal, and if the critical angle goes like above 90, it get reflect back. It's all about like you will learn this all things in, I think, in ray optics. Yeah, in ray optics you will learn about this. Okay, leave it now. So the main topic is, whenever light travels from this medium to this medium, he said that the light, there is attraction force, because of that reason it get bent over it. Okay, so if it is getting bent over this, my doubt is why why it is get slow down, like whenever you go from one medium to another medium, if the attraction force is more of the denser medium like water, and because of that reason, if it is getting bent, then why the speed is not more than the air medium? Okay, one doubt. Second doubt is, if it is getting bent, okay, then how you will explain the law of diffraction? Okay, like law of diffraction says, as much as small hole you will put, that much big shadow you will get. Okay, like that much screen presence you will get. Okay, um for this I have one trade experiment, where it is. Yeah, yeah, it is. So I just hope it is visible to you. Okay, yeah, okay. So yeah, it is not working over here. Like here we can't zoom it on, zoom in and zoom in out. Okay, just I hope it is visible to you. You can see a small black paper over here, and a hole over here. Okay, so this is the hole, and this is the screen presence you are getting. Okay, if I make this circle big, just see it. Okay, I am making the circle big. Now what happened? The red light went down. Okay, okay, and if I make this circle small, the red light get increases. Okay, you can also see over here. So as per the Newton's theory, if the light is bending in this direction, why this image is like getting grower? Okay, it is like not according to him it is bending, it is not expanding. Okay, so if it is like bending, how you will explain this one? Okay, if the particle size is like getting small, why it is getting increasing? Okay, so yeah, this was also one thing that he was unable to explain. But yeah, at that time, imagining his situation, like his hypothesis was like so correct. It was like little bit satisfactory. Like yeah, it was like it was giving a satisfaction that it was looking little bit correct. Okay, now if anyone just learned like kinematics, let's say still rotational motion, you will say that yeah, this theory was totally correct, because you can't imagine like waves around us. Like you will think that what the joke you are doing, like is everything is a wave. Like for him wave is just like small curved lines. Okay, like this is the waves, where it is. Yeah, this is the waves. Okay, these are like small oscillating lines. How it can be like present in total nature, and also you will think like that. Okay, so anyone will not believe like Huygens theory. Okay, so but Huygens theory was like little bit practical, but in this use a lot of math. Okay, so just wait a minute, let me do this. Yeah, okay, I hope you can see this. Yeah, so what Huygens theory says? So Huygens theory says, okay, yeah, fine, great. So what Huygens theory says? So Huygens theory says that that every light is a form of a wave. Okay, so how every light is a form of a wave? Yeah, compare the wave light with water. Okay, if you make any disturbance in water, then it forms like a wave. Okay, so how the light is forming the wave? So what disturbance it is having? So the disturbance it is having is, it is having ether. Okay, like he said that in whole nature we got like ether. Okay, in whole nature we have like so much of ether, and that ether is making disturbance in this particle, in this waves. Okay, uh, yeah, I just noticed one point, that my explanation is so bad. Like it doesn't providing that quality that I thought to provide you. That was the reason I was not making this video, because I'm like not well prepared. Okay, sorry for this, but yeah, I will make it and I will post it, and I will try to learn with my mistakes. This is just my first video on physics, just bear it out. Okay, if you learn something new, something great, yeah, it is great. And if you don't learn anything, you can just go on physics wala. They have explained the same things. Like at present day, like you have like so many resources to learn the same topics. You can learn over there. You have Google, you have got like so many resources you can learn over there. Here I will try to add on little bit more. I just want to give a perfect content, but Yeah, I'm unable to give it, but yeah, let's try it. Let's don't get demotivated. Okay, so what I can said that every light is a form of wave. Okay, every matter is a form of wave, and any scientists have not believed in this. So just let me show. So we have explained the law of reflection. Okay, like Newton have explained his particle theory just using of the law of refraction. So I can also, if I can want to prove his theory, you should also explain the refraction law, and also the law of diffraction. Okay, if you prove these three things, then only you can say that yeah, Eigen's theory is correct. Okay, so what you have did is he said that let's take a incident let's take a incident ray. Okay, over here. So yeah, this is the incident ray that is falling on this. What you have said is same in this parallel you take one more incident ray. Okay, so yeah, so let's take one more incident ray over here. Okay, so now next what you have said is take one incident ray and draw her perpendicular to this. Okay, now we have drawn a perpendicular to this. So from now you have said take a compass. Okay, I'm not explaining in this. I am just rotate one what we say one derivation type, and I'm just giving you the derivation. Okay, this is form of a derivation like that. I can't explain it you because um, the reason is you just said that do these steps, then you will get your output. Like it is same like Python. In Python, as you design, if you want to make a calculator, you have to use some steps, and you get your calculator. If you want to use something, like you have some steps. In the same way, it this theory also have like some steps. Okay, if you follow them, the law of reflection get proofs. Okay, so just so what happened, okay, let's get back to the topic. So what happened is when two rays are getting incident over this, um, here at this point they're getting intersect. So what we have to do is we have to take from year to year, we have to take one radius, and we have to draw a circle with respect to this radius. Like okay, just say this is like 5 centimeters. Okay, so if it is a 5 centimeters, we have to draw a circle from with respect to this of 5 centimeters. Okay, uh, yeah, so here take a radius and draw a circle of 5 centimeters. Great. Yeah, we can also do this. um, okay, I hope it looks perfect. So yeah, this is a circle, and this I think this have a radius of 5 centimeters. Okay, so now what you have to do is you have to make the circle with respect to this tangent. Okay, just a minute, I got one idea. Okay, so yeah, this is the radius, we got it. So yeah, is it, I think we have to make the circle little. Okay, just a minute. Yeah, okay, circle is like perfect. So now I can't move this circle. Great. Okay. So what we have to do now? Okay. You got the whole process right. We have to take one circle. I just said your process. Now I'm not gonna explain it again. um, Sorry, it was my mistake, but I will learn how to use also this, or else I will use some whiteboard next time. Like, again, my excuse is this is my first lecture. Okay, so yeah, okay, it is done. Okay, now we have to we have drawn one circle, and let's say you got some arc over here. Okay, you got some arc over here, and what you have to do is you have to just draw a tangent. You have to just draw a tangent with respect to this line. Okay, now I have drawn the tangent, and now what you have to do is you have to take like 90 degrees to this tangent. Okay, so 90 degrees to this tangent is like this, and now what I have to do is this I have to draw over here. This is like a perpendicular line, and now this is the reflected ray. Okay, okay, great. What we have done now, like and it totally went from my head. Okay, and whatever I have explained you, it I don't think you got like any point, my any point. Okay, so let me try to explain it to you. So what Eigen was trying to say is, he was saying that every particle is a form of wave, and the light is always perpendicular to the tangent of the wave. Okay, like just same what Eigen was trying to say. If this is a wave, and this is the tangent to it, now this is the light that we are getting. Okay, this he was trying to say. So what happen is, if it is a wave, it is also here. Here also we got one wave. 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 One wave. One wave. In the same way, we got like infinite waves. Okay, in a straight line. Okay, here it is here. So in the straight line. So what we are doing is, here we are like here so with this circle, we got here like our arc, and we have drawn tangent to it, and we draw the perpendicular to it. Actually we have to draw a circle over here, and we have to draw a perpendicular to it, but because every wave is like connected in a straight line, so whatever you get over any wave any wave light, like if you get any particle slight direction, like parallel to it will be over here. Okay, like let's say you got one let's say you got this. Okay, so here it will be parallel to this will also be parallel, this will also be parallel, and in the same way. Okay, my drawing is a little bit bad, but my I hope my explanation is good enough. So because it is like this, parallel to this, we got this. Okay, now the point is why we are doing this. Okay, like why we are taking perpendicular, why this is the rule. So first of all, the rule is like if this will not be perpendicular, let's say it is like this. Okay, now what will happen is, yeah, I can say that wave always be in a sequence. Okay, just see this, wave is in a sequence. Like if it is getting small, it is getting small at a time, it is getting up at a time, the amplitude increasing it like in same time, like everything is going like same. Okay, and just see this wave. Okay, if now it is going in one direction with one speed. Okay, now if if this line is like not totally perpendicular. Okay, this is uh, this is the direction of light. Okay, if the direction of light becomes this, what will happen is it will get changed into components. Like one component will be in direction, one component will be in this direction. Okay, if the component will be in this direction, means there should be also there will be like one wave traveling over here and one wave traveling over here, and they will get intersect each other. And like this, the rule can't get continue. Okay, rule will get spoiled out. So for this reason, I have said no, you can't take any components, you have to take like only one direction. This will be the perpendicular. Okay, so because we are taking a perpendicular, that's the reason I have drawn all these waves, and the perpendicular to the wave is like reflected ray to this. Okay, and whatever reflected ray we got over here, we can also get like same reflected ray parallel to this over here. Okay, so this is just one imagination, and this was just imagination, this was like correct one. Okay, this is angle of reflection and angle of incidence, and here we use like little bit of geometry. Yeah, okay, let me say you this. So whatever you draw this, it should be like perpendicular to this line. Okay, so let me draw this it again for you. Okay, so yeah, so let me draw it for you again. So this is the line. Here you're getting one line, here you're getting one line. This is like a perpendicular line, and here you're drawing a arc and drawing a tangent to it, and the tangent be like, okay, so the tangent be like this. Okay, here just imagine that I have set you total diagram about the whole diagram. So yeah, okay, I have said about the whole diagram. So yeah, whatever tangent you have drawn, this you have to draw perpendicular to this. Okay, so one perpendicular to this, let's say it is a perpendicular, and one more perpendicular to like this. Okay, so yeah, this is the reflected ray, this is the reflected ray, and this is angle of incidence, angle of reflection. In this way I have tried to explain this um, this uh, how the reflection take place. Okay, in the help of light, and like Newton and Hagen proved that here is just with explanation explaining this one, and I can also prove this theory by explaining the diffraction law. Okay, so as per the diffraction law, let me show it on you. Let me show it 3D one, because I don't think I will be able to explain it you. Yeah, so here we are. So let's imagine this. Okay, no, I have to use paint. Okay, so what you wanted to say is, just a minute. Okay, so what you wanted to say is, here you have took one line, straight line, as it is like same diagram as a Young's double slit experiment. Okay, and here one line. Okay, So what you was saying is, one wave goes over here, and once when it comes here, like normally what we will think, as per the Newton's particle theory, we will think that wave will directly go here and it will just show it to here. But when we use like red light and red light or green light or blue light, what will happen is, uh, it just gets spread out, like the light goes like this, this light goes like this, and we always be unable to like learn how it is happening. So what happening is, as we said, light is the perpendicular of the tangent of the wave. So what happen is, here it is everywhere waves. And what are these waves? These waves are disturbance making in nature by ether. As per the Eigen said that everywhere is a wave, and that wave is formed by disturbance in nature of ether. Okay, so this a continuous straight line sequence, and here it get ends. Okay, so what happen is, now you can see that, like see, here you are getting like straight line. Okay, this is straight line. You can now have a common tangent for all this. Okay, but at the end what happen is, at the end, like if just say this one, this is like for this tangent is this, it's not like the tangent is like not this. Okay, like if you want to draw the okay, I'm sorry about what took place. Okay, where were we? Yeah, we were at the diffraction law. So what happened is, yeah, the double slit experiment, and I was saying that everything will have a common tangent, just as the last one will have like a tilted one, like the common tangents will be like coming this and this, and light will like go with one with this, one with this, one with this, and one with this, one with this, one with this. Okay, and because of that reason, a small light, like this light rays getting like diffracted, and it shows on a bigger screen. This is the reason that light gets diffract. So this was the reason gave by Eigen. Okay, and he was just imagining, he was just doing the imagination, like he never saw wave in the reality. Okay, he just imagined this, that everywhere is a wave, and the wave is like water, means the light is like water, and the disturbance occurrence that is taking place is due to form of ether, like ether is in a infinite volume. Okay, this was is diffraction law. Okay, now let's discuss little bit about Young's double slit experiment, and after that, what we will do is, we will go with this little bit 3D animation and all, and then after this, I will say you, if you want to like make stronger imagination power, what chapters you have to go through it. Okay, so first let's complete this, because the time is like morning 4:22. Yeah, just a minute, let me go F5. Yeah, so yeah, time is like morning 4:22, and still we have not completed this, and after completing this I have to post it. Okay, so yeah, where were we? Yeah, we were at Young's double slit experiment. So according to Young's double slit experiment, what he was saying is, he was saying that if the light is in the waveform, here you will get like some light bands like this, and you will get like some dark bands and light bands. You would have heard about this in your 8th standard. Okay, in 8th standard they say about this. Okay, about the dark band and about the bright band. Okay, so uh, what happened is why it is showing like some dark bands, why it is showing like some bright band. So whenever a ray traveling over here, let's say it is traveling like this and it is traveling like this, but you can notice that this light wave is traveling extra distance compared to this. Okay, draw one perpendicular to this. Okay, so the distance extra traveled by this line is this much. Okay, so it is traveling like this much, and because it is in wave, what happen if the light comes over here and it cancel out each other. Okay, yes, the waves also can cancel out each other. Okay, if the way, just imagine that the first line wave is this and the second line wave is like this will get cancelled out each other, and it will become zero, and this zero is the dark band, and if they like meet with each other, and it becomes like a big wave. Okay, and this big wave is the brightest band. Okay, and remaining part is like a little bit normal. Okay, so yeah, this is also one thing that I wanted to explain you. uh, I think I made it like so much short explanation. Okay, and let's see this waves. So first I need to make this out, this one out, and initial width. Yeah, this is the formation of wave. Initial position. Yeah, the wave is like forming now, and the formation is getting like plane wave. We are done. So like in wave also we have two types. One is like wave packet and another is plane wave. Okay, so wave packet, like first let's discuss about this plane wave. So yeah, the distance between these 2 points is like amplitude, and they are like now oscillating it. um, um this is like for double slit experiment. Just let me play it for you. So you can see that when a light is like going over here, it is getting diffracted. One is going like this and one is going like this. What is happening is uh, over here a wave is forming in this direction. One tangent is coming here and the perpendicular to it is this direction, and that's the reason that it is going in this direction. Okay, and same with this one. Okay, now just say screen brightness. Okay, screen brightness, let it be vertical position, and you can see the, if we like, if it get like some closer, it look like this, and if it get more closer it look like this, and if it like go like in this, then you can see it is like just doing like little bit one, and yeah, slit separation. If the slit separation is like so less, wait a minute, let me explain it to you with the help of this, yeah, this one. Okay, so first let me draw this to red. Okay, when it is so small, the diffraction taking place in such a way that here you can see a big one, and If this get bigger, this gets smaller. This is the simple rule that you can say. And yeah, this is just, yeah, I wanted to show it to you, but now time is like 4:30. You can say 4:30. I have to refresh this page always just to show you the correct time. And I'm like I'm like little bit tired now. Like it's 4:30. I have not slept, and I will say you sorry that for this I'm not for this session I'm like not planned so much. I've just on my camera. I was just little bit confident that I can speak about this. I can explain this topic you to you in a very great way. But yeah, I got fail like I was unable to explain you like so many topics, and you would have got like so many doubts. I know that because I was in your stage, and I know if you are studying something like so seriously and we get doubts, and if they don't get clarified how it like feels like totally we think about that doubt, and we just try to sort it out. So yeah, I know, but like I'm just learning now how to teach, and yeah, from the next session I will come with little bit more explanation. Like first I will explain it to mirror, then I will come on camera. Like this time I've not done like anything. I just came on camera. I just started my speaking. Okay, and another thing is like I don't speak English in a frequent way. Okay, like frequently I don't speak English. My native language is Hindi, so I speak Hindi, and also I speak Telugu in my daily way language. Okay, like English I just speak in front of camera. So for this reason, like my English is like little bit weak, and so many points I know, like so many points that I get in my mind. I can't explain it to you in English. Okay, and in Hindi, like we have already got like so many amazing videos, so many amazing sessions that made by like so many people. So yeah, I don't want it to go with Hindi, and also I want to speak my English. I want to make better my English speaking skills. Okay, yeah. Like last one more thing, that I want to say you that if you want to make stronger your imagination power, like how much stronger, like let me just give you example. Like what is my imagination power? Like in real, if I take this two fingers, and if I draw a line like this, okay, just say this. Okay, now in my imagination I can see a line over here. If my eyes are open, then also I can see a line over here, and I can also imagine a line over here, and some particles coming from here, some particles going like this. Like this is the something about the imagination power. Okay, so if you want to master in physics, if you want to get great in physics, you just need to learn how to imagine things out. Okay, so how you can learn how to imagine? Okay, so if you want to learn it how to imagine it, just learn kinematics. Okay, in kinematics, rain man problems, lift man problems, there you will learn so many things. Like you will get starting imagining things, and till the rotational motion you will get perfect in imagining things. Okay, like this particle can come over this rod, have moment of inertia over here, so it is rotating with respect to this point, and this point is at rest, this point is at movement, and like so many things you can just imagine them with the help of imagination for sure. Okay, so if you make stronger your mechanics, what they use is number one, the 1125 unlock 11 to 50% syllabus complete, to and 11, 10, 12 combined 25% syllabus complete. Third benefit is obviously the imagination part that you're getting. Fourth benefit is that mechanics is used in in so many chapters, like electrostatics it get used, ray optics it get used. Like I get just give you example of mirror. Okay, if mirror you get like particles on that and it goes that all part that I have explained you was totally of kinematics part, and I am explaining it to you in this wave chapter. So just imagine how much important this kind of mechanics part is. So just don't leave it, study about that, and learn how to imagine things. And next video will be on Python, and Python video will not like this. Yeah, obviously it will like theory based, because this week I have not learned like so many things. I've just learned about this wrap, how to comment on, and if else statement, and using if else statement I will try to make one calculator. And I don't know how to make a calculator, but just we are gonna see, or just we are gonna check our luck if it work out or not. And yeah, now I'm going to bed because time is like, just give me a minute, time is 4:35 a.m. And yes, now I'm not gonna post this video, because I am not gonna post this video for now, because already it is 4:35. I have to make thumbnail for this video, and I have to cut like small little bit parts where I have said something like extra. I have to cut that part. And also to export these videos, it take me like 3 to 4 hours of time, so I just don't want to do all this stuff. I will just go to bed, I will sleep. Time is 4:35 a.m. I think I will sleep till 6 or 7, and at 7 we will start uploading this video. Till 11 it will get uploaded, and at 12 or 1 I will learn little bit about Python, but theory part, and I will start the video, and I will try to don't keep it like this session. I know this session was like so bad. I'm sorry for this. I will try to make it better till the next session. Okay, and yeah, for sure on math I will make one video in the coming time. Okay, so I'm getting so much sleep. So okay, bye. Good night. I'm signing off. Okay, so yeah, they passed like this. Like today, it is like next day of the recording. Actually, it is today. So it is afternoon, 3 o'clock. I'm just recording the end part of the video, because I thought that yesterday I have not gave a proper ending. So it's just the reason I'm giving it an end. And also I know that the video was like not at all perfect. Actually, I don't think that anyone will see this. Okay, because I know that my explanation was like so weak, and compared to other teachers, it was like just waste. You can say like just totally garbage. So yeah, but this was my first video on the physics, so I think it can work. And also I've not planned anything, like I just made it. I don't wanted to break my consistency. Already I've missed my one. I thought to make one video on this last week, but I have not made it. And also if I will skip this week, like it will go like totally waste. So I don't wanted to do that. That was the reason that whatever it is, just make it. So yeah, I've just made it. I've not thought like so much about that what will happen and how it will go on, if anyone will still see the video or not. Just I made it took I actually have not made this video for you. Actually, I made this video just for myself, just just to not break my consistency and just to see what are the weak points I have, like what is in weak, what is weak in me. Like, and yesterday while I was explaining you these topics, I was like so nervous. Okay, you can notice like in at the starting at the starting point of the video, I was unable to like carry on. I was unable, like my brain was not working, what I have to say, like what I have to speak. So I just saw the camera and I was just laughing because my brain like gone totally blank. Then while I was explaining you some things, like I was getting like in my brain it was getting reminder, yeah, okay, I have to explain also this, no, I have to also explain this, yes, we have to explain this. So because the session was like totally unplanned, like as well as like how my brain was recollecting the things, I was delivering them. That was the reason that, and I have not planned like how to explain this topic. Okay, in this way we can explain it. So yeah, teaching is a little bit tougher part, so we have to plan it for this. Like my one mistake that I have noticed is planning. So yeah, okay, I will say you that what mistakes I have noticed in the yesterday session. Number one, planning. Number two, execution. Number three, number number three is what is this? Um, Wait a minute. Let me say you. Yeah, forgetting things out. Like whenever I go on speaking, like I forget some things to speak. So that is one more point. And fourth, my English speaking skills. Okay, yesterday there was a point where I know that what this meaning is. Like I could explain you the topic in a better way if I used to explain you in Hindi, but in English, like I'm just learning now English, so it is just little bit harder for me to explain any topic in English. So yeah, there I am lagging, so I have to also work on that. So many things to work on. Okay, yeah, that is a thing. And yeah, I will try to improve day by day. Like I will try that the next part of my video should be like little bit more good, more explanative. Like I should be able to explain like more better things in more better way, with more concepts, with more feel. Okay, because like how my sir explained me was like just amazing. Like till now I've not forgot like so many things. Like it is in my brain. Like what is rotation, like what is moment of inertia, rotational motion, and all the Newton's laws of motion, and circular motion, motion in a plane, motion in two dimension, and motion in a straight line. So many things. Okay, work, power, energy, all these chapters were like of totally feel. Okay, you can only feel them. So if you want to make your imagination power stronger, just go with mechanics, just complete it. If you complete mechanics, you can like study any chapter of physics, just take it randomly and just go on. You can like complete it in like two 2 hours, not 2 hours, not say 1 day or 2 days. I will not say that in 1 day or 2 day you will like get total clarity about the chapter and everything, but yeah, you will be able to crack any exam, like till the level of J means, or uh, like if J advanced paper came some easy, you can clear till the J advanced. Just go with mechanics, get full feel of mechanics. Just give it like 3 to 4 months of 3 to 4 months span of time to just learn mechanics. Okay, I'm saying it for some guys who take long term. Okay, just give 3 to 4 months of your time to mechanics, and in the remaining 3 to 4 months, I am saying you can complete total 11th remaining physics and 12 physics. Okay, the rest of the part is like so much easy. It's just a little bit of theory and a little bit of mechanics. In electrostatics also, it is a use of mechanics. Okay, when electrons like attract each other, and when electron is in like in open space, it gives one electric field and um, direction of field lines. Okay, so yeah, leave it. It is like a totally another matter. The and just I'm saying you is just go with mechanics if you want to imagine things out. This is the one thing. And the second thing, I know that so many people will not watch this, and I'm just making this end part of the video just for myself, just to see myself in future. Because like nowadays, I'm getting change in every 6 months. Like 6 months back I was a different person, now I'm a different person, and I don't know when I will get change. Like in coming 6 months I can get like totally change. So I just want to see my past. I just want to record my past, so that I can learn what mistakes I have made in my past, and so that I don't repeat it back. Okay, this is the one more reason that I'm making this end part of the video just for myself. And thank you if anyone is seeing this end part. Okay, yeah, what else? Like max of the things I've said you. And also one more time, sorry for this session if any of my friend is watching it. So sorry to him or her that I made like this session, because it was like so just a waste of time. Because I made this session of how much time I have made it, like 43 1 hour 1 hour 8 minutes 1 hour 15, yeah. 1 hour 15 minutes have explained you such topics that you can learn in just 5 to 10 minutes. Have gone through like 1 hour 15 minutes, and I don't think I have talked like anything important over in this 1 hour 15 minute session. I have just talked about the learn mechanics, and um, I was just doing that vector form and all. So sorry for this session. I will try to improve it. And yeah, one more thing, one more reason that I'm recording session is just I'm thinking it as a JE mock test. Okay, JE or NEET mock test. So whenever you give your mock test, like weekly mock test, you never be ready for that. Okay, you never be like confident, no I can give this mock test. You always be in doubt, no now I'm not ready, now no not now, not now, not now. And so my students, what they do is they just skipping they just big skipping this mock test series. And because of this that reason they messed up, they make mess up in the final exams, like the JMS exams. So I don't want it to be like that. I don't want it to skip my session just because of that the way I'm not ready, I'm not perfect, I don't know anything. Just I thought that okay, I don't know anything. What I know, let's make it a video on that. So I just made it like and yeah, I like in my imagination, my okay, I also want to share about my imagination. Okay, in my imagination, what I wanted to explain was like, yeah, okay, the level of the explanation that I wanted to give you is here, and what I have explained you is here, yeah, at ground you can say. So yeah, this was a big difference, and I want to cover this difference as soon as possible. I will not say that I will cover this in 1 week or 1 month, but I don't know how much time, how much span it will take. But yeah, one day um, I will cross this level, and I will go at at that level. Okay, I will try my level best. And okay, if anyone is like indie speaking guy, and you want to learn something related to physics, I have some opinions, like I have some suggestions for you. One is Salim sir. Salim sir is best in part of feeling, in just taking the feel of physics. just go with Salim sir. Salim sir is best. No, you and if you want like slow explanation, like so basic one, go with Alak Pandey sir. He's just very good at basics. He just clear out the basics. I'm not saying that Salim sir don't clear, but he just focus on getting things imagine or solving questions. Like is like for advanced level you can go with Salim sir, and for mains level or neat level you can go with Alak Pandey sir. And in physics there are like so many great teachers available, NV sir and a lot more, but I have not studied from them, so I can't suggest their names to you. I can suggest Salim sir and Alak Pandey sir, from whom I have studied and from whom I got the feel of physics. Okay, yeah, that's the one more thing I wanted to say you. Is there anything else that I can say, that I can talk about? Yeah, my sessions are like mostly it goes in just talking like some waste things. I was gonna use some other word, but I don't wanted to use it, so I just use this word wastage. Okay, yeah, my most of the time goes in just time pass. Why I do this? I do this just for fun. I love speaking in front of camera. Okay, I just love it. I just wanted to go speak continuously without stopping. And if I know any topic, I just want to continuously explain it to you. Okay, like my fan is like closed, and I'm like, yeah, it is like so hot. It is like I am feeling like little bit irritating, but yeah, still it is like fun for me. I just love it to make videos on YouTube, just do time pass. It's not mean that time pass. It just is. I get it is just for fun for me. I just love making videos. I just love to talk with you. I just love to talk in front of camera, that in English, because my English is like so weak. I don't know how I'm speaking this much time continuously in English, because if I go in front of anyone and if I try to talk with him or her, then what will happen is in just 5 to 10 minutes I will be like this. Uh, 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 okay, okay, like this. Okay, like after 5 minutes there will be nothing at me to speak. Like I will get blank to tell. Like I will in my brain it will not come. Like now next what I have to speak. Okay, and here I don't know how I am able to like speak continuously, like for hours. Like the last session that I made, I speak the English for continuously for 3 hours. This session I am recording, I speak like for 1 hour 50 minutes, that to physics. Okay, physics is just a total subject of field. Okay, and I am explaining you the subject of field in the language that I don't know totally. Like, so it was just an amazing experience for me. Just it was just fun, and next time I will try to make it better and better. Okay, okay, next time what my target is, let me say you. Number one target is something on maths. I want to make something on maths, because Python is completed, physics is completed, my favorite subject is um, being backside. So one I have to do that, I have to work on that. And secondly, I also want to make some video on physics, that wave equations, Schrodinger wave equation, matter waves, and the progress hypothesis. Okay, I want to make a video on this, and I want to give a better explanation to you. Okay, and also I will say little bit basics about the waves, because at this time I have not said you that. Okay, and what else we can do else, like we can also go with like some Python assignments. Okay, Like, yeah, I will make one Python assignment, I will make one Python video. Okay, yeah, I will. And today also I will be making one more video on Python. It will be, for sure it will be night. In day I can't take this risk. At night, 10 or 11 I will start recording my session. In days I just ate to make videos, I just ate to record something. In night, yeah, it is great, I can do this. Okay, I'm just closing now. Yeah, I'm done. Yeah, I speak continuously for 7 minutes. Just see it. Like, it's just amazing for me because I don't know how I'm speaking this much. Okay. Yeah. So now what I will do, I will just edit this video a little bit, and I will post it, and let's see if I will make any video on Python or not. I'm just thinking to say something about the theory part and just a little bit of assignments. Okay, assignments. Yeah. Okay. I just don't wanted to end this video. I just want to continue it, but no, we have to. If we are starting something, we have to give it a end. So yeah, I have to close this video. Just give me a minute. Yeah, this is here. Okay, great. Yeah, what I'm doing now, I'm just seeing what I can do. Yeah, great. Now I have to close the video. I don't want to do that. I just want to speak with you guys something. Okay, for sure, if I will get like 1000 or 2000 subscribers, I'm gonna make a live session, and there we will like talk so many things. Okay, like so many things about what? About me, about the topics that I teach, what I've did in my last year, and all this stuff. Yeah, I just wanted to see how many views I got like for that master Python class, and I got like 180 views. Okay, and my subscribers count is 63 subscribers. Okay, I will be frank, they all are my college mates. Have, like, I don't think anyone have genuinely subscribed me. Like, they all, I think they all know me. Yeah, there can be like 4 to 5 guys who have genuinely subscribed me, like who they are. Okay, like when I was doing this live sessions, then I got some subscribers, like 4 to 5. They are from UP. They are like my genuine subscribers. I don't know if they are following me or not. Okay, if you are following, just give me a comment, or else I will think that yeah, you are not following me, and all this is 63 subscribers are my friends. Okay, yeah, great. um what I what else we can do? Like, max out the parts got completed. 20 minutes I was just continuously speaking, and still I don't want to close the video. I just want to continue it, but yeah, okay, I will close it. I will. Yeah, I don't want to, but yeah, I have to close it. Like, I can't be speaking continuously for the whole day. Okay, and yes, for sure, I'm gonna make one video on Python theory part, and I got one like 3 assignments. I'm gonna do the 3 assignments just over here. And what else I can do? Yeah, this much part I'm gonna do this. And also I got something to do in physics, but yeah, in physics homework, like physics I have like went so faster, and I'm like, so I have got so many backlogs to clear in physics. I have to work on that. And in maths I will make it in next week because tomorrow is my college. I can't be just making videos continuously like whole night. Okay, I just can make one video in a day. So yeah, I will try to make one video on Python just today. Yeah, great. Yeah, this sound is like so satisfactory. Yeah, okay, I am closing the video. Yeah, okay, done. Tata, bye bye.